Okay, it's being recorded now. Okay, Akram asked about antisymmetric. Okay, to understand antisymmetric, you need to understand a symmetric first. Okay, symmetric. Alright, I tried. Saya tak present ni, present. Okay, boleh nampak Okay, symmetric, as the name implies, there exists AB for all AB in R. Okay, for this instance, ini senang nak nampak because for terbalik. There exists the mirror of AB in R for every BA which exists in R. Okay, ni senang. Maksudnya, contohnya, okay, if 1, 2 is inside R, then it is symmetric if 2, 1 is also inside R. Ini yang Akram cakap tadi, dia bagi contoh 1, 2, right? Okay, first of all, I would like to ask you guys, okay, this is 1, this is 2, this is 2, and this is 1. Obviously, 1 is not equal to 2. Okay, establish that mind first. Establish the fact first. 1 is not equal to 2. Okay, antisymmetric. An extra note I think I need to mention is that not symmetric, it does not equal to antisymmetric. Tak sama. Tak semestinya bermaksud ini. So that's why if it is symmetric, it does not necessarily must be antisymmetric and vice versa. And then I mentioned is that in the notes I said that it cannot be both symmetric and antisymmetric. It can be both for only one relation. Later I will show you. Establish that not symmetric is not equal to antisymmetric. It's totally a different relation. So what is antisymmetric basically is that there exists AB in R for every BA in R. Nampak sama, tapi dia tambah satu, only when A equals to B. You have one more condition here is that the symmetric exists only when A equals to B. Alright? So, sekejap. Kita tunjuk contoh ini. Suppose I give an undefined relation. Let R equals to, saya letaklah 1, 2, 2, 1, 1, 1. Okay. Two different questions. The first one I want to ask whether this is symmetric or not. The second one is that I ask whether it is anti-symmetric or not. Okay, saya tak tengok korang punya chat apa-apa sila suarakan. Okay. The first one, it is symmetric or not? You check 1, 2. Ada tak 2, 1? Ada. Okay. There exists 2, 1 for 1, 2. Fair enough. Untuk 2, 1 pula, there exists 1, 2 for 2, 1. Okay. Now we arrive at this one, 1, 1. There exists 1, 1, kalau kita terbalikkan, for 1, 1. So, for the first question, is it symmetric or not? Yes. It is symmetric. And my reasoning is already been shown on the left, here. For each one element, saya bagi tahu. For 2, 1, 1, 2 ada. For 1, 2, 2, 1 ada. For 1, 1, 1, 1 ada. Because 1, 1, when we try to inverse it, it will be 1, 1. Okay, now we move to a separate question, antisymmetric. Is it antisymmetric or not? Cuba korang tengok definition kat atas ni. Saya tak tunjuk, saya tak tutup. There exists AB for BA only when A equals to B. So kalau kau tengok ni, adakah ini antisymmetric? There exists 2, 1, 4, 1, 2. But 1 is not equal to 2. The symmetry exists, but not only when A equals to B. So for this case, I already show my counter example is that no, it is not anti-symmetric. Because AB exists for BA, but A is not equal to B. Okay, saya kecilkan dulu. Ada soalan tak? Orang ni kadang tanya Chef, apa ni, transitive sikit sir? Boleh habis. Okay, reflect yourself on this thinking first. Beza, symmetric and anti-symmetric is different because you need to check for this one. So for this undefined relation, the first question A, it is symmetric and it is also not anti-symmetric. Okay, let's look at the different question here. Let R equals to 1, 2. No, tak mau 1, 2. Saya ambil 1, 1, 2, 2, 3, 3. This time it's different. Still an undefined relation. Undefined tu maksudnya saya tak cakap A less than B, A tambah B sama dengan 2, tak. Saya tak sebut. Just directly ordered pairs terus. Itu undefined relation. Two question. Is it symmetric? And of course the second one, is it anti-symmetric? Okay, one by one. The thinking of symmetric first. Is it symmetric? There exists 1, 1 for 1, 1. There exists 2, 2 for 2, 2. There exists 3, 3 kalau kita terbalikkan, also 3, 3 for 3, 3. Yes, it is symmetric, definitely. As you observe here, I don't really need to check whether it's equal or not, because the definition for symmetric is only as simple as BA for AB or AB for BA. But for anti-symmetric, I need to check whether it is equal or not for every element. There exists 1, 1 for 1, 1. 1 equals to 1. How about 2, 2? 2, 2, the mirror AB, 2, 2, 2 equals to 2. And also 3, 3 exists for 3, 3. And does it satisfy A equals to B? Yes. Therefore, the conclusion is that it is anti-symmetric as well. So try to reflect this different question and how we answer it. I repeat, if you want to check for the symmetricness, you only need to check BA, AB. BA, AB. Okay? But for anti-symmetric, BA, AB equal or not?
Sir.
Ya, bercakap.
Contoh kalau dekat kan sekarang kita ada 1, 1, 2, 2, 3, 3 kan. Kalau saya tambah 2, 1 macam mana?
Soalan mana ni? B, A ke B?
B, B.
Okay.
Kalau saya tambah, kan sekarang ada 1, 1, 2, 2, 3, 3 kan. Kalau saya tambah 2, 1, dia akan jadi lain ke tak?
Okay, kalau kamu tambah, maksudnya jadi soalan lain lah, betul? Okay, saya cuba tulis balik soalan yang diajukan. Let R be 1, 1, 2, 2, 3, 3, Tiba-tiba tambah lagi 2, 1. Okay. Simetrik atau tidak? Soalan yang bagus sebab dia ubah kat sini. Okay, tambah 1, 2, 1 je Okay, symmetric or not?
Tak.
Tak, kenapa?
Sebab tak ada 1, 2.
Betul. Senang kan? There does not exist 1, 2 for 2, 1. So for the case of the question of symmetric or not, it is not symmetric. Although 1, 1 exists for 1, 1, 2, 2 exists for 2, 2, 3, 3, 4 exists for 3, 3, but 1, 2 does not exist for 2, 1. Therefore not symmetric. Symmetric kacang senang. Yang ni student sometimes confused. Antisymmetric pula. Ni careful Ini saya kena ulang pelan-pelan. Okay, 1, 1 There exists 1, 1 for 1, 1. Sama lah, 1 equals to 1. There exists 2, 2 for 2, 2. 2 equals to 2. There exists 3, 3 for 3, 3. 3 equals to 3. Sampai yang kat last ni. Patut tak saya check whether 2, 1 exists for 1, 2? Tak perlu. Betul. Sebab there does not exist 1, 2 for 2, 1. So you don't really need to check whether 2 equals to 1 or not. Kerana kita tengok balik definition sebelum korang pening. There exists AB for BA only when A equals to B. It means if does not exist BA for AB, tak perlulah check only when A equals to B. So for this case, alamak, undo. Okay, for this case, for 2, 1, no need to check. Atau we really don't care whether 1 is equal to 2 or not. So the second one, it is antisymmetric. Because BA exists for AB only when A equals to B. If it is not equal, you don't need to check anymore. Okay, sekejap saya tengok ada chat. Ya, cakap.
Kiranya dekat situ kita skip lah sebab dia tak ada relation tu.
Betul.
Okay, thank you sir.
Alright, let's move forward to a case of a defined relation. Selalunya soalan saya campur lah undefined dengan defined. Case defined macam ni. Alright. Okay. Let R be defined as an ordered pairs such that A larger than or equal to B. Ni biasa saya tanya. Okay. Saya define A adalah Z kali Z. A less than B. Or A larger than B tadi. Okay. Kalau case ni infinite, saya buat kecil sikit lah. Takut korang pening. Saya buat kecil sikit. Kecil tu macam ni. Let A be defined as 1, 2, 3. Ada 3 elemen saja. And then the relation is being defined as an ordered pairs from A times A. Maksudnya kita ada berapa kat dalam ni? 3 kali 3 kita ada 9 ordered pairs. Such that A larger than B. In the previous lecture, I said that the easiest way for you to do this is try to do the Cartesian product first for every element. 1, 1, 2, 2. Nanti tak nampak. 1, 1, 1, 2 dulu. Cartesian product senang. Semua boleh jawab itu quiz. 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Although it is not really compulsory for you to do the Cartesian product if I ask about the relation. Okay, yang manakah dalam relation ini? Yang mana A larger than or equal to B. So saya tulislah 1, 1, 1, 2 tak ada 1, 3 tak ada. 2, 1, 2, 2. Okay, yang ada 3, 1, 3, 2, 3, 3. Okay, this one So, is it symmetric? So, saya kena check satu-satu. Kalau symmetric, 1, 1, symmetric There exists 1, 1 for 1, 1. There exists 2, 1, but tak ada. There does not exist 1, 2 for 2, 1. Saya dah nampak dah. Untuk 2, 1, dalam ni tak ada 1, 2. Not symmetric. Okay. Saya rasa yang ni tak ada masalah. How about NT? Yang mana kita ada satu lagi condition. It must be only when A equals to B. There exists 1, 1 for 1, 1. 1 equals to 1. Nampak? Penyelesaian dia hampir sama dengan yang sebelum ni soalan. 2, 1 perlu tak kita check? 2, 1, 1, 2 tak ada. Tak payahlah check whether is equal or not. So you nak tulis boleh, you tak tulis pun tak apa. You boleh ignore. And this is quite obvious that the symmetry of BA and AB only exists only when it is equal. So, to reflect for this question, there exists BA for AB when A equals to B. So, my conclusion is that it is anti-symmetric. Although it is not symmetric, but for the question of anti-symmetric, it is anti-symmetric. Okey, ada soalan?
Sir.
Ya, bercakap.
Sir, dalam nota tu, dalam nota tu dia kata a relation cannot be both.
Okey, saya dah cakap dah dalam kelas lepas dan saya cakap lagi sekali.
Okay.
Dia boleh sama, dia selalunya tidak sama. Selalunya dia tidak sama, tetapi ada satu condition yang mana dia boleh berlaku, dia simetrik dan anti-simetrik. Boleh. So, padamlah kamu dekat perkataan tu.
Okay, sorry.
Tak apa. Yang penting kita saling mengingatkan. Itulah kelemahan online class. Kadang-kadang kita terleka sedikit pun atau kamu pergi buat something, kita terlepas. Tapi tak apa. At least kamu bertanya Hafiz. Hafiz ke? Imran? Tak tahu, saya tak nampak nama. Tapi the thing is, it can be both only for one case. Apakah case itu? Case dia ialah bila, satu je. Dalam banyak-banyak relation yang saya buat, satu je yang both symmetric and anti-symmetric. Saya dah buat kat atas tadi. Iaitu bila R, AB, A equals to B. A equals to B. Tak kisahlah dalam mana-mana domain, whether it's a finite set, A equals to 1, 2, 3 or any integer kali integer. Kalau relation A equals to B, guarantee dia symmetric dan guarantee dia anti-symmetric. Ada soalan lain? Sebelum saya proceed ke transitif. Ini bahaya. Selalunya student dia silap dekat anti-symmetric. So make sure careful. This is a good session anyway, is that you know to differentiate anti-symmetric dengan symmetric. Apa beza dia? Dekat sini je. It changes everything. Alright. Now to transitive, seperti permintaan kawan kamu satu. Maybe a very brief one. I try. Okay, about transitive. There exists AC for AB and BC. Kalau nak lagi cantik, for all lah, A, B and BC. You know, it's really good if you manage to produce back the definition to guide you again. Kalau korang perasan saya tak buka nota sebab ada sebab saya nak tulis lagi senang nampak semua. Tapi lagi satu dia nak train supaya saya ingat apakah itu transitive. Okay, transitive is like a bridge tau. Nampak tak? A, B, B, C. Maka adanya AC. If you can go from A to B and there exists B to C, there must be A to C as well. Okay, let's start with the motivation of this. A equals to 1, 2, 3. I put it in a finite set and R is defined as apa ni? A, B, A larger than B yang kita buat tadi. Alright, so this relation will have 1, 1, 2, 1, 2, 2, 3, 1, 3, 2, and 3, 3. Okay, let's look the idea on transitiveness. Okay, you check 1, 1. 1, 1, you try to pair it with the thing at the one at the front. Ada tak? Tak ada. Yang ada satu-satu. So normally the logic satu-satu, kalau dia sama, satu-satu, dia kalau katakan ni A, ni B, ni B, ni C, adanya satu-satu. Ni AC. So if the A equals to B type, 1, 1, 2, 2, 3, 3. Sekejap Okay. So selalunya orang tak tulis pun tak apa kalau student tak tulis. Tapi kalau tulis lagi bagus. Maksud saya kalau kita nak lihat there exists 1, 1 for 1, 1 and 1, 1. This is quite intuitive because 1, 1, 1, 1 AC dia pun 1, 1 lah. Tak menarik lagi kat situ. Cuba kita tengok yang berbeza. Okay, saya ambil. Kita pairkan 2, 1 and 1, 1. Ni A, ni B, ni B, ni C. Ada tak AC? Jadi 2, 1 betul? So, ni AC dia. So, untuk case 2, 1, 1, 1, 2, 1 pun dia transitive. Masih intuitif, tetapi tidak untuk kes ini. Kita ambil yang lagi menarik. 3, 2 and 2, 1. Dalam kes ni A different, B different, C pun different. A 3, B 2, C 1. Ada tak 3, 1 dalam relation ini? Three, 1 exists, right? Ni tengok ni. 3, 2, 2, 1, AC, 3, 1 exists. So the relation Kalau kita tengok, kita check semua ni, kita kena check for all possible pair of AB and BC. At the end, you will see that it is transitive. Untuk case finite, you kena mention all possible combination. Ada lagi combination yang saya tak buat. 3-2, 2-2 jadi 3-2. 3-3, 3-3, 3-3. But the idea remains the same. You need to find A, B, where B sama dengan B yang sebelum ni, BC, dia jadi AC. Sometimes it's easier for you macam mana to think about this infinitely. Kenapa saya cakap infinite kadang-kadang lagi senang? Ini contoh saya. R sama dengan ordered pairs which is a product of integer times integer, A larger than B. Okay, ni minta beri perhatian. Saya rasa saya cakap ni dalam video saya, tapi mungkin saya tak ingat. So sekarang ni cuba fokus untuk case infinite sekejap. Kadang-kadang dia lagi senang. Okay, the question, is it transitive or not? And justify the reason. According to the definition of transitive, it must state that AC exists for AB and BC. Cuba tengok macam mana saya nak bawa pemikiran ni ke sini. If AB is inside R, maka A larger than B berdasarkan relation ini. I must try to find BC. If BC is inside of R, then B is larger than C. Okay? Inilah, kalau tadi ni kiri kanan kan, ni kiri kanan, B mesti larger than C. So, questionnya, bila I have the A larger than or equal to B and B larger than or equal to C. As A larger than B and B larger than C, of course A larger than C. Implies A larger than C. Logik kan? A larger than or equal to B, B is larger than or equal to C, maka A mestilah larger than or equal to C. So, AC adalah dalam R ini. Okay, now I open to question. Ya, saya.
Kalau yang contoh first yang saya tunjuk ni, kalau 2-1 dengan 3-3 kan tak ada kan 2-3.
Ulang balik. Kalau 2-1 dengan 3-3,
kan tak, yang 2-3 tak ada. So dia bukan transitif lah.
Yang kiri ke? Okey, sekejap. Soalan kawan kamu ialah 2-1 3-3, betul? Okey, saya kecilkan kepada 2-1 dan 3-3 je sebab dia mention kalau 2-1 dan 3-3, adakah ini transitif atau tidak? Mari kita berfikir kejap.
Dia tak ada dalam relation kan sir?
Dia tak ada, bukan tak ada relation, apa? Dia tak ada condition dia. Ni. 2-1 dengan 3-3. Okey, untuk 2-1, ada tak ordered pairs yang lain yang depan dia 1? Dalam kes ni, yang kecil ni. 2-1, 3-3. Tak ada. You cannot find AB, you cannot find BC. No BC. So my point right now, kalau kita tak ada condition BC tersebut, maka dia transitif. Kerana kita tak jumpa dia punya BC. Argument ni sama dengan antisimetrik tadi. Kalau 2-1 tak ada 1-2, you don't need to check for AC. Therefore, it is transitive. Kalau 3-3 ada kan, 3-3 and 3-3 jadilah 3-3. Bagus tak soalan kawan-kawan tanya ni? Sebab ada student confused, kalau 2-1 3-3 tak sama. Kalau 3-3 kita tak boleh compare. 2-1 cannot be comparable with 3-3. Cannot, because it is not the same B. Ni 1, ni 3, tak boleh. Kamu tak boleh kata 2-3 tak ada, tak boleh. Tak boleh. Sebab for AB, you must find BC yang mana B tu adalah sama. Kalau tak sama, itu bukan B lah. Itu merupakan elemen yang lain, bukannya B. So untuk menjawab soalan Syazah saya rasa tadi, ialah if 2-1, 3-3, you don't compare them as A, B and BC together. You cannot. Therefore, for 2-1, jangan compare dengan 3-3. Mestilah 2-3 tak ada. Jawapan dia bukannya not transitive. Dia akan still transitive. Good question. Saya rasa cover semua masalah common student. Ada soalan lain? Ingat cari B yang sama ya. Kalau kamu perasan, dekat comparison yang saya buat di kiri ini, 1-1, dia mesti sama 1 ke sini. 2-1 dengan 1-2. AC tak sama tak apa, tapi B kena sama. 3-2, 2-1. Okey, soalan lain jika ada?
Sir.
Ya.
Okey,
Lain,
contoh
lain.
dekat dalam satu relation tu kan, kita ada 1-3.
Okey, ni soalan lain jadi saya kena catat jap. Katakan dalam satu relation ada 1-3, ni undefined 1-3.
1-3.
Aha.
Lepas tu kita ada 3-2.
3-2.
Itu saja.
Alright. Untuk soalan ni. Aha. Kiranya transitif ke tidak ni?
Tak.
Tak, kenapa?
Sebab AC tak ada kan sir?
Betul. Alright. Soalan yang dinyatakan oleh sahabat kamu ni ialah kalau kita ada 1-3-3-2 sahaja. Kejap saya charge laptop. Okey. Okey. For this question of undefined relation, you only have 1-3 and 3-2. Okay? So, for this case, you have the B. B tu maksudnya B yang sama. So, you check 1-3 and 3-2. This is A, this is B, this is B, this is C. So, you have a B right now. It is transitive if AC ada. Tetapi 1-2 tak ada kat dalam R ini. Tak ada. Yang ni you kena check because you exist B, the same B, but unfortunately AC does not exist in here. Therefore, R is not transitive. Very good. Betul belaka. Pemahaman yang jelas. Jangan pula suddenly contoh jawapan yang silap ialah kamu ambil 3-2 and 1-3. But 3-3 is not inside R. Mestilah tak ada 3-3, tak peduli pun sebab this is not the same B. So this is wrong if you try to do the second way. But the first one, you have 1-3, 3-2. Ini kena compare. Ini you kena cari AC. But for the second one, which I pangkah banyak ni, ialah comparison of AB and BC yang kurang tepat. Dia betul, dia not transitive. Okay, let's look at advanced example. Saya pernah tanya soalan ni dekat final exam dulu. Soalan original daripada saya fikir sendiri. Sebab student selalu dapat equality, tambah, tolak, senang. So, I try to challenge them at the final exam. Okay. This is an infinite ordered pairs of integer times integer such that a squared plus b squared equals to c squared. Ni persamaan apa ni? Siapa boleh bagi tahu? Impress me. It's a Pythagoras, right? Such that a squared plus b squared equals to c squared. This is a Pythagoras theorem. Okay, dan dia merupakan relation antara A dengan B yang mana C menghasilkan C dan C ni mestilah juga integer. So soalan yang saya tanya, saya tak ingatlah saya tanya soalan apa. Is this Pythagorean theorem reflexive? Is it symmetric? Is it anti-symmetric? And of course, I can ask whether this is transitive or not. Saya boleh, kamu nak saya jawab, saya akan jawab satu je daripada semua ni. Kamu nak saya jawab yang mana? Yang lain saya berjadikan kamu sebagai homework. Maksudnya, saya dah ada idea dah untuk kamu punya assignment. Assignment kamu kali ni bukannya Pythagorean theorem. Saya nak tanya pasal Goldbach conjecture. Nanti saya akan buat soalan tu, akan tanya kepada korang sebagai assignment. Tetapi untuk soalan ini, saya offer diri saya untuk jawab satu je relation. Yang mana yang kamu nak? Jangan cakap semua, saya kata satu-satulah.
Try anti-symmetric.
Okay, anti-symmetric So, A, B, D, kamu cuba jawab sendiri. Kalau kamu dapat jawab, maka memang wow lah. Maksudnya kamu faham lah, insyaAllah. Okay, so kawan kamu menyuruh saya untuk anti-symmetric. Okay, this is actually how I will answer this question. First of all, I would like to remind myself what is anti-symmetric. There is this BA in R for AB only when A equals to B. Kawan-kamu tu memang bijak. Dia tahu kalau saya jawab anti-symmetric, saya jawab symmetric tu. Sebab ada BA, AB. Tapi ada beza AB equals to B. Alright. Tak ada masalah. Okay. The solution. I must try to find what is AB first. If AB is inside R, maka A squared plus B squared equals to C squared. Katakan BA juga wujud. So, B squared plus A squared sama dengan C squared. Betul? A squared tambah B squared sama dengan C squared. B squared tambah A squared juga sama dengan C squared. So dalam kes ni saya dah tunjuk dah kepada kamu, dia simetrik. Memang dia simetrik. Kerana A squared plus B squared is commutative as B squared plus A squared. The problem right now, the trick to this question, only when A equals to B. Okay. Apakah contoh Pythagorean theorem? Apakah contoh ordered pairs yang ada dalam relation ini? Pertama sekali 3, 4 ke? 3, 4 ada dalam R. Sebab 3 squared plus 4 squared equals to 5 squared. 6, 8 ada tak dalam R ni? Ada. Sebab 6 squared plus 8 squared equals to 10 squared. But the problem right now I try to tackle is that only when A equals to B. Alright, dalam kes ni A equals to B, ini yang menjadi masalah. Okay, saya gunakan counter example saya 3, 4. 3, 4 is inside R and 4, 3 is inside R, betul?
Betul.
3 squared plus 4 squared equals to 5 squared. Kalau 4, 3 pula, 4 squared tambah 3 squared sama dengan 5 squared based on the previous argument here. But 3 is not equal to 4. So as my conclusion, there exists 3, 4 in R. This is by counter example, and 4, 3 in R. But 3 is not equal to 4. Therefore, not anti-symmetric. Sekian, terima kasih. So, saya dah bukan kebetulan lah. Symmetric kita dah tahu symmetric, anti-symmetric kita dah tahu not anti-symmetric. So, task kepada kamu ialah try to think, is it reflexive or not? Is it transitive or not? Kalau kamu boleh jawab A dengan D, boleh dapat dah 4 markah untuk final exam yang lepas. Sebab sem ni saya tak buat lagi soalan. So, Charles Laptop, thank you Aiman. Dah. Alright. I leave this working here for you to take the idea. Idea saya yang pertama ialah always write back the definition to guide me, and then I bring the condition here so I can see the outcomes of the relation. The outcome of the relation with some logical explanation of the proving essence. Maksud saya, kalau dia betul, kamu kena tunjukkan semua betul dalam general statement. Kalau salah, saya tunjuk counter example. Because this question is not anti-symmetric, is enough for me to show counter example. Conclusion. We take a break for a while for 3 minutes before we proceed back with our new module. Okay, boleh rehat sekejap. Apa ni? Jadi nanti saya oh, by the way, you guys, UMP sekarang ni ada 2 staff positif COVID-19. Semua seram. So, wherever you are, please take care of yourself. Jaga SOP. Kalau tak perlu keluar, jangan keluar. Kuantan makin naik baru-baru ini, tetapi tidak seseram Selangor. Menunjukkan peningkatan. So, like I said, please take care of yourself. tahu gejala-gejala dia. Selangor tak ada nampak penurunan. Saya setuju Muhsin. Sebab tapi kluster pekerjaan banyak daripada kilang-kilang. So jangan pergi kilang ya Muhsin. Mana tahu kamu part time tiba-tiba okey lah. Pergilah kerja kilang. Jadi Pak Gad. Pak Gad tu meninggal. Pak Gad Top Glove meninggal. Dunia semalam. Yes, muda. Dia lambat lah tu. Saya rasa dia tak mau pergi klinik, dia rasa dia boleh sihat sendiri. Okay, by the way, some of the obvious symptom that I heard about the COVID-19 is that bukan saja demam. Demam ni kamu confuse tau kadang-kadang. Kadang-kadang kita sesama biasa pun kita demam biasa pun kita demam kan. So ada setengah orang ingat, oh demam ni bukan COVID ni demam biasa ni. Kadang-kadang kamu batuk, alah batuk biasa, betul. Simptom dia sama. Tetapi yang agak membezakan ialah there's a report of loss of taste, sense of taste, hilang. Makan tak rasa. Itu saya baca banyak. So kalau kamu tiba-tiba makan KFC tapi kamu tak rasa KFC, oh bau sabun? Ya betul Hafiz. Ada ke bau sabun? Maybe. Saya tak tahu kamu baca mana. Tapi saya baca dia tak rasa benda. Kalau kamu rasa kamu demam tapi kamu makan tak rasa apa, standby lah tu. Melainkan kalau kamu memang makanan tu tak ada garam ke, memang tak ada rasa ke, atau kamu tak ada lidah ke, itu mungkin lah. Okay, rehat sekejap. Saya nak dulu. Saya off kamera sekejap Blackpink lagu apa? Cepat. Tajuk lagu. Saya tak dengar sangat Blackpink tapi nak Blackpink lagu benda. Cepat. Hafiz Ashraf. Oh, minat K-pop Sasageyo. Allah. Nak eja macam mana ni aku nak search pun Sasageyo. Benda Sasageyo ni. Tak ada pun. Apa kepelik student aku ni? Shit. Ni lagu benda. Yelah lagu Naruto pun lagu benda. Okey, kita kembali ke dunia nyata yang mana tanpa anime ni. Okey, maksudnya anime masih ada peminat dia. Saya baca Attack on Titan tapi manga. Saya baca manga dulu. Sampai dah tak ada masa nak baca dah. Ada Titan besar, ada Titan kecil, ada Titan perempuan. Pandai dia orang ni. Fikir idea untuk buat cerita. Kenapa kita Malaysia tak ada penulis komik yang macam tu? Okay, number theory saya ready. Saya standby buka. Mantul lu benda Aizat Aikal. Oh, anak PA aku ni. Mantul lu benda, mantul. Oh. Salam. Saya balas WhatsApp kawan saya, WhatsApp kawan kamu sekejap. Bagi tahu yang lain mana. Lain tu kat mana? Nanti saya. Mantap betul lah, baru betul lah apa patulah cahaya. Baru faham, mantul, mantap betul. Okey. Bahasa budak sekarang. Alright. Kita kembali kepada modul baru. Okey. Saya cek WhatsApp sekejap. Tak ada. Okey, hari ni kita pergi ke asas saja. Kita present now. Okey. Number theory. Alright, when we talk about number theory, we must first know a little bit of a number system. Okay, we have a large group of real number. Okay, real number. Then the set which are mutually exclusive with real number is imaginary number. Imaginary number ialah contohnya, contoh imaginary number, sebab saya tak tulis imaginary number kat sini, adalah square root of -1. Square root of -1, it's equals to an imaginary value of I. So it's not real. It does not exist because you tak dapat cari apa A times B equals to -1. No. Salah tu. You tak dapat cari A squared equals to -1. Ada chat ke? Saya tak tengok chat. Ni lah tekan-tekan kalau kita keluar I tu. Yes, itu imaginary number. Because A squared equals to -1. A equals to I. Tak ada. Dia bukan tak ada lah, dia ada lah. Mathematician renames this as an imaginary number. So this is a huge class of set of number. Okay. Lawan kepada imaginary number ialah real number. Real number. Dan bawah real number ada rational number and irrational number. Okay, this one it will be quite brief because you don't need to know every types of number for this chapter. Okay. Later I explain why. Okay, rational number is a number that can be put into P over Q. It means the number is in the form of a ratio. Irrational number a number that cannot be represented as a ratio. Bukannya nombor ni tak betul bukan nombor ni gila, dia irrational. It cannot be put in the form of ratio. The famous form of irrational number is pi. And by the way, pi, definitionally speaking, is not equal to 22/7. This bukannya 22/7 sebenarnya. Pi is approximately 22/7. It is not equal. Sebab tu pi, kalau kamu letak equal, ialah 3.14, saya tak hafal. Dia 141 something blah 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 blah. The decimal is endless. So if its number is rational, irrational, no repeating decimals. Apa perkataan English infinite decimals. Okay, I pergi dulu kepada first point. Kalau kita cakap rational number tak boleh ada repeating decimal, dia boleh repeat. Contoh 0.99999, it's infinite as well. 0.9999 ni. Tetapi kalau kamu letak dalam kalkulator 0.999 ni sama dengan apa? Dia still boleh dalam bentuk ratio. Kalau 0.123123123, it's still infinite decimal. Tetapi dia boleh dalam bentuk satu pecahan kat sini. Kamu boleh cari apa dia. Tetapi kalau case untuk non-repeating, adalah infinite decimal and there is no pattern in the decimal, therefore the number is actually cannot be put into a ratio. Therefore it is irrational. This is a famous example, pi. There are also natural logarithm is also a constant which is irrational. Tak perlu hafal sangat yang ni. Sebab number theory kita tak belajar semua jenis nombor. Then in rational number there's a huge class of integer. Ini yang kita nak fokus. Because number theory is the study of integers. Okay, so integers, my students already know, we already shown this a couple of times, is symbolized by this symbol, integer z. And in integer, we have positive integer, we have negative integer, we have zero, which is neither positive nor negative integer. Okay, apakah dia natural numbers? Yang mana merupakan sebahagian daripada integer. There are two teachings daripada dua fahaman mathematician. Natural number ada yang melibatkan kosong. So they put n kosong. 0, 1, 2, 3 until a very large integer. Ada pula satu fahaman yang meletakkan natural number tidak termasuk kosong. 1, 2, 3 until a very large integer. Seriously, there are two definitions. But for me, natural number saya follow yang mana? Kenapa nama dia natural by the way? Because that is how we count. Okay, sebutkan kira nombor. 1, 2, 3, 4. Orang tak akan cakap, okay, contoh saya tanya anak saya lah. Tak boleh lagi mengira dia tu. Contoh saya tanya, okay Anas, cuba kira nombor. Dia tak akan cakap 1/2, 2/3, 3/5, 4/5. 5.0 dia tak akan cakap macam tu. Dia naturally we will count in the basic counting principle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Itu yang selalu kita ajar. But for me, in my philosophy, I trust that natural number is better appropriate be defined at the second one. It must also include 0. Tapi kamu jangan risau, soalan saya akan mention selalunya natural number tu termasuk kosong atau tidak. So jangan takutlah saya nak guna yang mana. Saya akan mention sama ada Z plus, Z negatif, Z saja atau Z tu termasuk 0. Saya mesti akan define. Don't worry about that. But I do really believe, because there are two ways of thinking from the different perspective of mathematician, kosong ni termasuk ke tak. Kalau saya, natural number mesti masuk kosong. Because 0 is really important, introduced by the Hindus, Indian mathematician to show nothingness. Kita kena ada satu natural nombor yang kalau kita nak kira mesti termasuk kosong. That's why how many students attend my class today? 0. Itulah natural lah. How many attend my class today? 23. Itu natural numbers. It is not natural for me to say there is negative 20 students who attend my class today. That is so not natural. Actually, negative number, they say, in some of my readings, they say that actually it does not exist in the real world anyway. It can always be put into the scale of 0. Contoh saya nak cakap kat sini ialah temperature. Contohlah temperature. Kenapa ada negative temperature? Bolehkah negatif tu disetkan sebagai 0? Ini kalau kita sembang antara saintis, physics, sebab tu wujudnya absolute zero. Kelvin, contoh, ni pengetahuan tambahan saja. So make sure you know what is integer. For this chapter, it's important for you to know about the concept of integer atau nombor bulat. Alright, ni is a simple true or false. Ni bukannya saya punya ayat lah ni, kawan saya ambil daripada buku Rosen tu. An integer is also rational, of course. A rational number is not necessarily an integer, of course. And a number is either blah 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 but not both. Baca sendirilah yang ni. Okay, the concept of factorability or divisibility. Tengok chat jap. Ada tak kamu tanya soalan? Apa ni? Hahaha. Haha budak type ke? Okay. Concept of divisibility Kita pergi kepada beberapa teori. Divisibility or some say in Batam factorability. Faktor and divisible. Okay. A is a factor of B. Okay, kejap. Saya tulis balik. Oh, ni ada definition dekat sini tapi saya tunjuk. Let A be an element of integer. A is a factor of B or A divides B. If B can be represented equally as the product of A times C. This C must be integer. By this context, A is factor of B. Vice versa, B is multiple of A. Dulu di sekolah, kamu belajar 3 faktor kepada 6. 3 is a factor of 6. But why? 3 is a factor of 6. If we want to check whether 3 is a factor of 6 or not, it must be made equal as 6 equals to 3 times C. This C must be integer. The question right now is C an integer? If it is yes, then definitely 3 is a factor of 6. If this does not, then 3 is not a factor of 6. 6 can be made as 3 times 2. 2 is definitely an integer. My conclusion is that 3 is definitely a factor of 6. 6 is also a multiple of 3. And based on by this simple proof also, it shows that 2 is a factor of 6 as well. Now let's try to determine the question. Is 3 a factor of 10? If it is factor of 10, then 10 can be made as 3 times c, c is an integer. 10 equals to 3 times 10 over 3. And this 10 over 3 is not an integer. It cannot be simplified into an integer form. As my result, I say 3 is not, letak slash kat sana, a factor of 10. And 10 is also not a multiple of 3. Ini sama je dengan yang kiri, cuma saya tunjuk contoh dia. Ada satu sahabat kamu yang ingat tak dalam kuliah sebelum ni? Yang mana kita berbincang pasal ini. Sekejap saya buka. 0. Is it a factor of 5? And vice versa, is 5 a factor of 0? Sahabat kamu personal WhatsApp saya last sekali jawab, lagi elok kalau ditanya dalam grup supaya ramai boleh tahu. So sekarang ni cuba kita fikir sejenak. Is 0 a factor of 5?
No.
Kenapa? Boleh tak kita buktikan?
Boleh. Macam tak boleh.
Boleh. Kalau kamu ada definition itu, ini definitionnya saya dah buka kat sebelah. Is 0 a factor of 5? The question, if it can, then 5 equals to 0 times c. This c must be an integer. The question right now, what is this c? Zero darab benda dapat 5.
Tak boleh.
Therefore, C is undefined. Therefore, 0 is not a factor of C. Dalam kes ni, saya tak mau jawab C bukannya integer. Kita tak tahu pun C itu apa. So we can assume to say that 0 is not a factor of 5. Therefore, that's why you put 5 divide by 0 dalam calculator, dia keluar math error, right? I don't sure dia keluar math error kan. It's undefined. But that is not the same case for 5. Is it a factor of 0?
Yes.
0 equals to 5 times C. C must be an integer kan? Apakah C itu?
0.
Ini clear. Ini memang clear. C is defined. And C equals to 0. 0 is an integer. Therefore, it is conclusive that 5 is a factor of the 0. And indeed, every integer is a factor of 0. Betul ke claim saya ni? 0, is it a factor of 0? Of course, what? 0 is 0 times C. Yeah, C must be 0 as well. Alright, so it already answers, do you ever y an integer? I cannot also. Ni soalan saya ni, ayat saya ni. because it is undefined. We cannot know the factors of 0. The 0 is not a factor. Okay, ini penjelasan saja. There are several theorems that can be associated with dates. Yang ni saya tak cadang tanya kamu dah pasal proving methods. Sebelum ni untuk DMA memang saya ajar benda ni. Untuk kamu mungkin saya tanya sebagai assignment atau pengetahuan tambahan sajalah. Okay, there are several theorems associated with this. For example, if A is a factor of B and A is a factor of C, then definitely A is a factor of the summation of B and C. Ini fakta. Contoh, I take 3 is a factor of 6 and 3 is a factor of 12 as well. This theorem states that 3 must be a factor of 6 plus 12. And definitely 3 is a factor of 18. I can prove this, but I don't want to right now. We don't have that time. For the second question, theorem, if A is a factor of B, then A, it must be a factor of a scalar product of B and C for every integer C. So, for example, if 3 is a factor of 6, then definitely 3 is a factor of 6 times something. For example, 6 times 8. And definitely 3 is a factor of 48. There is also an illustration of this theorem. And lastly is the transitive. Kalau korang perasan ni transitive. If A is a factor of B and B is a factor of C. Nampak ni? A, B, B, C. Then A is also a factor of C. This is a transitive relation reflected by this example. 3 is a factor of 6. I take one more, 6 is a factor of 24. 3 is also a factor of 24. Okay, kita ada 15 minit lagi. Saya nak habiskan dekat prime. Okay, the definition of a prime number is a number which has exactly two factors. Prime number, a positive integer, larger than 1, it has exactly only two factors, which is the first one, 1, and also itself. So if any positive integer which is larger than 1, it has exactly two factors, then definitely it is a prime number. And oppositely, if the number has more than two factors, then it is composite. Lawan kepada prime ialah composite. So, what is the smallest prime number?
What? 2.
Okay, tengok definitionnya. Positive integer larger than 1. Maka 1 is not a prime number. Actually, I can explain why 1 is not a prime number. But maybe later in the lecture. The smallest prime number is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, blah 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 blah. Oh, ada. Okay. Sometimes, okay, it's a quite advantage if you manage to memorize the smaller prime. Okay, kerana teknik ni akan kita guna untuk prime factorization nanti. Alright, I want to teach you a method of prime factorization later kalau ada masa. Kita pergi dulu kepada fundamental theorem of arithmetic. Okay, this is very important theorem of arithmetic, which is not being taught in the previous level of teaching, I suppose. Fundamental theorem of arithmetic states that every positive integer larger than 1 can be represented uniquely as the product of prime. Okay, apa maksud dia? Any positive integer larger than 1 can be represented as a product of prime. Okay. So, in other words, if I put it in a general statement, let A be a positive integer and A must be larger than 1, this A can be represented as a product of prime. Katakan P1 times P2 times until Pn. Bukan Perikatan Nasional, Pn, a finite number of n. Where this must be primes. P is prime. So, let me show you an example. Okay, I take the smallest, 2. Can it be represented as a product of prime? Boleh, kerana 2 is 2 times 1. It is a prime number itself. 3, 2 times 1, 3 to the power of 1. Still a product of prime. 4, which is our smallest composite integer. Bolehkah kita represent ni sebagai hasil darab prime?
Tak. 2 power 2.
Betul. It is 2 times 2. In the canonical power form is 2 to the power of 2. Tak challenging kita ambil nombor besar sikit. 10. Apakah product of prime dia? 2 times 5. Okay, we have 4 examples right now. And based on these 4 examples of these 4 integers 2, 3, 4 and 10, all of them can be represented as a product of prime. One more thing to mention is that based on the fundamental theorem of arithmetic, it says that it can be represented uniquely. You know, every positive integer is like there is an IC for them. Ada identity unique kepada mereka. When it says unique, if 10 is 2 to the power of 1 times 5 to the power of 1, there will never be other integer which is 2 to the power of 1 times 5 to the power of 1. Guaranteed. So this is a unique representation of an integer. Later I will, maybe in this Thursday, I will teach you how we want to factorize number into primes. For example, if I take a large one, 1, 2, 0, what is the product of primes associated with 1, 2, 0? Okay, kita boleh tahu menggunakan teknik prime factorization. Ada dalam nota, kamu boleh tengok nanti. Okay, Theorem number 2, how to test. Ni ambil calculator, korang ready yang calculator kejap. Saya bawa calculator, saya bawa. Okay. How to check whether a number is a prime number or not. Okay, kamu tak payah hafal pun sebenarnya. Contoh 121 is prime or not. Siapa hafal? Siapa boleh tahu? Siapa hafal? 121 ni prime atau tidak? Tanpa tengok nota, tanpa tengok nota, tanpa tengok internet, 121 ni prime atau tidak?
Prime.
Kamu hafal
No, not prime.
Ui, kalau hafal saya besarkan lagi. Tak mau ambil 121, saya ambil 1201. Is prime or not? Besar sangat lah. 19 Aish. 191, prime ke tidak? Okey.
Tak tahu.
Tak tahu. Okey. Sekarang saya akan ajar macam mana kita nak check dia prime atau tidak. Okey. Baca dulu teorem 2. If n is a composite integer, then n has a prime divisor less than or equal to a square root of n. Okey. So kalau kita tahu dia composite atau tidak, maka kita pun tahu dia tu prime atau tidak lah. So first of all, you need to find the square root of 191. Nanti saya buktikan untuk 121 Okay. Sekarang ni, what is a square root 191?
13.82.
Thank you. Thank you. That's 13.82 something 13.82. So, kalau kita nak tengok, baca betul-betul, 191 is composite if 191 has prime divisor atau prime factor less than or equal to square root of 191. Okay, so apa yang kamu kena buat, kita kena check ada tak prime factor less than or equal to square root of 191. So, saya kena check 2, is it the factor of 191? Kamu ambil calculator, kamu boleh bahagi lurus. 191 divided by 2, is it a decimal or not? If it is a decimal, then 2 is not a factor of 191. Okay, 2 is not a factor of 191. 3, is it the factor of 191?
No.
Thank you for your answer, saya tak perlu check. Okay, what is the next prime factor? 5. Is it the factor of 191?
No.
Of course not. Next, 7.
Tak.
Tak juga. What is the next prime? 7, 11.
Tak juga.
Tak juga. Now, we arrive at our right now, less than 13. Maksudnya kita kena check sampai 13. 13 adalah faktor 191 atau tidak?
Tak.
Tidak juga. Okay, I don't need to check beyond this 13.82. Okay, tak perlu dah. Sebab dia cakap kalau 191 dia composite, maka dia mesti ada, it must have prime factor. But based on our testing until 2, 3, 5, 7, 11, 13, enough, it does not has a prime factor. What I can conclusively say that 191 does not have a prime factor less than or square root of 191. So 191 is prime. Satu lagi contoh. Ni confirm prime Saya ambil nombor yang kecil sikit. 100, is it? Tak mencabarlah. 152, boleh? 153? 153 lah. Okay, prime or not? So, if it's is a composite, then it must have a prime divisor up until less than square root 153. So square root 153 is 12.
3, 6, 3, 7.
Okay, cukup. Kira maksudnya bukan kata tapi dia sampai square root sampai 12 saja. So saya kena check kalau dia composite maka dia ada prime factor up until 12. So 2, is it the factor of 153? No. 3, is it the factor of 153?
Yes.
Yes. Okay. So, because it has a prime factor less than 12, which is 3 by the way, therefore 153 is composite. Or in other words, it is not prime. So, this is a primality test yang kita panggil sebagai primality test. So lepas ni kamu dah ada pengetahuan ni, boleh juga check whether sekejap. Okay. 1 to 1 is a prime or not. You can all actually check it. 1 to 1, is it prime or not? You can check by finding a factor of prime factor up until square root of 1 to 1. Kawan kamu cakap dia prime. Kalau dia cakap dia prime, maka dia tiada prime factor up until square root 1 to 1. Okay? So I will stop here. There are infinitely many prime ni, betul lah. Okay. Saya nak kamu buka Wiki sekejap. Cuba type dalam group, dalam Google, sorry. Largest prime number. Saya tak buka lah, saya baca dekat handphone saya saja. Okay, what is the largest known prime number? Okay. Because surprisingly, prime number ni sangat banyak. Okay. The largest known prime number according to the Wiki as of November is 2 to the power of 82,589,933 minus 1. Nombor ini sangat besar. Sangat besar. And interestingly, there are no factors for it. Okay, boleh tengok internet lah sendiri. Saya tak mau tunjuk dah, dah pukul 12 dah. So, Euclid already proven that prime is infinite. And the super duper computer still search for the next largest prime number. I will stop here and we will continue this lecture on Thursday. Okay, with more concept of prime factorization and divisibility. I will stop present right now. Oh, thank you. Bagi tahu. Okay. Oh, rajin type. Terima kasih. I will stop recording right now. Ada apa-apa soalan tak sebelum kita sambung hari Khamis ini?